Hi everyone, I'm 1B. This is the third lecture, Principles of Statistics. When we get some data set that is simple, then we want to know the dispersion degree, how widely or narrowly spread the data set is. So we get what? Sample variance. For a sample, x1, x2, xn, there are n many sample values. We define the variance. Variance what? Average of squared deviations. What is deviation? Xi minus x bar. X bar is the mean. I 1, 2 up to n. X1 minus x bar, x2 minus x bar, dot dot dot, xn minus x bar are deviations. We call them deviations, right? So squared it and average, then we get variance. It is important to note that we divide by n minus 1, even though it is, we say average instead of n. Okay, so sample variance S square can be obtained, calculated as follow: x1 minus x bar square, x2 minus x bar square, xn minus x bar square, divided by n minus 1. Right? We defined sample variance formula like this. Shortly, the numerator is xi minus x bar square sigma I from 1 to n. Everybody knows this notation. Otherwise, if you do not know this notation, then you will be in trouble to follow these lectures. Okay? Anyway, in the numerator of s square, this one, which is the sum of squares of n deviations, but it is divided by degrees of freedom n minus 1. In this case, n minus 1 is degrees of freedom. So what is degrees of freedom? Degrees of freedom refer to the number of independent quantities. Number of independent quantities, okay? Degrees of freedom is the number of independent quantities. You better memorize this kind of thing. It's just simple. You do not know, you do not understand what the degrees of freedom is. Let's say, in a sample, x1, x2, xn, the number of independent quantities is n. Sample values are independent. The sample values are obtained independently each other, okay? Sample values are independent. Otherwise, there is no statistics. This is a basic concept or definition like that. We will see it later too. However, for the n deviations, x1 minus x bar, x2 minus x bar, xn minus x bar, n deviations, the number of independent quantities among the deviations, n deviations, is n minus 1. Why? This is because the deviations include the sample mean x bar. Sample mean x bar is included in each deviation. You got it? No? Then let's see. In other words, when the value of x bar is fixed means known. If n values of xi are determined independently, then the remaining value is automatically obtained. So not independent. There are n deviations. Each deviation includes x bar. So this one is fixed, is known, then in other words, x bar is known. Okay? Let's see simple example. As a simple example, for sample of size 3, x1, x2, x3, okay? The sample size is 3, then 3 values. The number of independent quantities here, in here, is 3, right? However, for 3 deviations, x1 minus x bar, x2 minus x bar, x3 minus x bar, the number of independent quantities is what? 3 minus 1, 2. in practice, among the three deviations here, x1 minus x bar, x2 minus x bar, x3 minus x bar, if any two are independently obtained as some real value, 7 minus 5, 6 minus 5, okay? This one is a 7 minus 5, this one is a 6 minus 5, then what is x3 minus x bar? It is automatically determined 2 minus 5, 2 minus 5. Why? We already know x bar is 5. Then x1, x2, x3 is what? 15. So they x1 is 6, x2 is 7, x2 is 6, then x3 is what? 2, right? So the remaining deviation must be 2 minus 5, not independent, right? This is because the value of x bar is fixed at 5. Okay? It is not magic. The same logic applies regardless of which number, whatever number are pre-arbitrarily chosen. You choose. I'm choosing another case if two deviations are independently obtained at 300 minus 600, 700 minus 600, then the last one, remaining one, should be 800 minus 600 deviation. Why? X bar equal to 600 fixed, determined. Then x1, x2, x3, x3 is what? 1800. So there they are 300, 700 independently determined, right? Then the last one, remaining one is what? 800. 800 minus third, the remaining deviation should be 800 minus 600. So they are only two deviations are independent in this case, in this example. All right, I believe you understand this concept. What is degrees of freedom? In statistics, the concept of degrees of freedom is important. Here and there, you will meet degrees of freedom, especially when you analyze data with computer, okay? Particularly because it always arises in statistical analysis, it is essential to understand and grasp this concept. However, okay, I understand what the degrees of freedom is, but however, why do we divide by degrees of freedom n minus 1 when calculating the sample variance? Okay, you understand, I understand, everybody understands degrees of freedom. Then why we divide by degrees of freedom? There is some theoretical basis. The reason why for this will be explained in the upcoming section on estimation. So you have to wait until when we study estimation, then it will be clear. Okay, this is the end today. Thank you. Bye.